Hi guys, in deep learning experiment 3 is all about image classification. So in this the goal of the project is to build a convolutional neural network using a TensorFlow and Keras to classify images from a Cipher10 dataset. Is a well-known image classification dataset that contains 60,000 images. In this the size of a image is 32 cross 32 pixel. So let's go into the program. First, we import necessary libraries. TensorFlow and Keras are used to build and train our deep learning model. From Keras, we import layers and models to create our CNN, convolutional neural network. We also import Cipher10 dataset, which is a popular dataset for image classification. The Cipher10 dataset has 60,000 color image divided into 10 categories. The categories like aeroplanes, cars, birds, cats, dogs, and more. There are 50,000 image for training and 10,000 image for testing. Next, we load and normalize the data. When we load it, see, loading and normalizing it. Okay. Then when we load x underscore train and x underscore test contain the image and y underscore train and y underscore test contains the labels. We divide all pixel values by 255 so that the number go from 0 to 1 instead of 0 to 255. This normalization helps the model train faster and perform better. Now we are building the CNN model. The first page is con-D layer with 32 filters and the 3 cross 3 kernel size and the activation function of ReLU. Next, we add a max pooling 2D layer which reduces the size of the image by taking the maximum value from each region. Then we add another convolution 2D layer with 64 filters to learn more complex pattern again. Now we follow it for a max pooling 2D layer. The same like a second layer, the third layer is also followed. Then we add another con 2D layer with 64 filters to learn more complex pattern again. After that, we use a flattened layer to convert the 2D image data into a 1D array. So we can pass it into a fully connected layer. Then we add a dense layer with 64 neurons and ReLU activation, which helps the model learn relationship between features. Finally, we add an output layer with the 10 neurons and a softmax activation function, which gives the probabilities for each of the 10 classes like aeroplane, cat, and ship, etc. Next, we compile the model using a Adam optimizer to control how the model learn and loss function. We use a loss function called space underscore categorical underscore cross entropy. Since our output labels are integers, we also track accuracy to see how well the model is doing during training the model. Then we train the model. Then we train the model for 10 approach. It means that through entire training dataset, the dataset is going on 10 times. Finally, we evaluate using a evaluation function. We print the accurate test accuracy, which tells us how well our model performs on a new image. Usually, the CNN achieves around 70 to 75% accuracy depending on the training. Thank you.